No, that's there for a purpose.
Oh, the water.
Yeah.
Hydration.
How the water evolved and turned into bottled water.
I like it. That's pretty cool. Every week we're balancing stuff.
Alhamdulillah Rabbil Alameen. Wassalatu wassalamu ala Rasul Kareem wa ala alihi wa sahbihi ajma'in. I'd just like to welcome all the brothers to today's discussion. Inshallah, brothers, just before we start, just an announcement, inshallah, the next few weeks we've got a new series of talks happening. I'll get Alex to pass it on. It's basically talking about why non-Muslims turn to Islam. And we'll have, speakers coming down, people who actually embrace Islam from different faiths. So people who are previously Hindus, atheists, and this kind of people, they'll be coming down, talking about what attracted them to Islam, the struggles they went through, and how Islam changed their lives. Inshallah, that's from next week we'll start. So, brothers, I'll ask all of you to tell other people, invite others, bring them down from next week. But inshallah, brothers, today's discussion, got Brother Nazmul, he'll be talking about this concept, this idea of evolution. And you find that, especially in the Western societies, this idea of evolution is actually, if you go to school, this is something that's pushed to everybody, that this is how we came. Most of the Western thinkers and they in the media, this is what they're pushing, that the universe and the world and the things around it, that's how we came about. So we've got Brother Nazmul to talk about, this issue of evolution. Is that, is that fact or fiction? So inshallah, Nazmul will be talking about this.
Alhamdulillah Rabbil Alameen, wa salatu wa salam ala Sayyidina Muhammad wa alihi wa sahbihi ajma'in. It's not in the name of Allah, the Lord, the Creator, Master of the whole universe, who created man and jinn for a purpose, and also even the animals He has created, as well as the whole earth and what it surrounds it. So inshallah, I've left something in front of you so you can sort of look at the sort of ideas out there. I mean, today's circle, to be honest, is not just about evolution. It's really about thinking, how to think to reach the truth. I mean, we've got the series coming up where people have come to Islam, and we want to look at the questions of why they came to Islam. And really, the focus of thinking is to come to the truth and be able to differentiate between the truth, the haqq, and the batil. So you have to know how to distinguish between the two. And this is the sort of thinking we want to actually bring, the intellectual thought, where you can actually look at the reality and look at all the factors surrounding an issue, and then come to the truth. But that means you need to actually think. You need to engage your brain, look at the issues, look at even the debates, things where something might be against what you might be holding. So therefore we're looking at evolution because it is a thought out there. Yeah? A lot of people, a lot of scientists actually do believe in evolution, and even in America there's a big debate going on between creationism and evolution. So therefore it is an idea that some people in society hold. What does Islam say on this? Okay? And what sort of thinking should we come to so that we can come to the truth? Okay? So we'll start there. In Surah Al-Baqarah, verse 164, Allah subhanahu wa ta'ala tells us about what we should be doing. Yeah? Bismillah ar-Rahman ar-Rahim. إن في خلق السماوات والأرض واختلاف الليل والنهار والفلك التي تجري في البحر بما ينفع الناس وما أنزل الله من السماء من ماء فأحيا به الأرض بعد موتها وبث فيها من كل دابة وتصريف الرياح والسحاب المسخر بين السماء والأرض لآيات لقوم يعقلون. The translation: verily in the creation of the heavens and the earth, and in the alternation of night and day, and the ships which sail through the sea, with that which is of use to mankind, and the water which Allah sends down from the sky and makes the earth alive therewith, after its death, and the moving creatures of all kinds that he has scattered therein, and in the veering of winds and clouds which are held between the sky and the earth, are indeed signs for people of intellect. Now the key issue there, the verb at the end, it says yaqilun. It comes from the Arabic word aql. Aql is the intellectual thought. Some people say the rational thought, the thought of the brain engaging with the reality, processing that information, and then coming to an idea. So it's about reality. It's not about going on to ideas that have been passed on to you from your schools or colleges or other scientists. That's what we want to build today, the correct way to think. And the best way is obviously from Allah subhanahu wa ta'ala, in Surah Al-Baqarah verse 164, as Allah says, that these are indeed signs, ayat, these are indeed signs for people who think, people who have that aql and use that aql. So this is what we need to do today, really to think, and that's why, one thing you should have all brought here today, even beyond mobiles and things, is really your brains, it's very important. Because you need to, because in schools, I'll be honest with you, when you study science, they sort of teach everything as facts. This is how the atom is. It's got protons and neutrons, electrons spinning around, it's like a sphere.
Sorry, which ayah? Sorry to interrupt you.
This is Surah Al-Baqarah verse 164.
164. Alright.
But they say that electrons are little balls flying around. But when you actually go deeper into it, when you go into the university level, you see a lot of things you have to learn are actually wrong. Electrons are not little balls spinning around with electric charge. They're actually clouds, electric clouds spinning around with negative charge. So therefore, even scientists have come out with new things. They've looked into development of existing technology and found out a lot more. But for Muslims, we can't just hold on to every little fact that people present to you and say, look, this is fact or this is reality, and we base our aqeedah on that. No, it shouldn't be that. What your aqeedah should be based on, what your belief, your creed should be based on, if you want to find the haqq, that is, like Muslims and non-Muslims who are sincere, want to find the truth. So how do you do that? So this is really about the focus of discussion today, and the first tip in that will be to look at reality, not theories, not people having doubts on issues or assumptions. That's not what I'm interested in. In natural science, we look at real proof, and that's what we're going to look at today. The proof of evolution, is there any? And if not, if this is wrong, what should be the actual state of affairs in the dunya? How did it all come about? Okay, so the first picture there, as you can see, we'll try and make it interactive today, so I'll ask you questions as well to see what you understand and what you think, so feel open, absolutely, Right, this thing, what creature is that? I want to hazard a guess what that is. It doesn't matter, by the way, one thing we start off with, it doesn't, I'm not too interested, for the whole discussion that is, I'm not too interested if you get it right or wrong. Any question,
Yeah, I was going to say that.
Have you ever seen, this is more interesting to the point, have you ever seen something like this in your back garden or anywhere else?
No. I've seen a frog, but
okay. The reason why it's an image, obviously that's not real, okay? And this is a point, it's a point to think about. Why have you not seen a frog like that? Why has a frog not evolved? You've heard about natural selection, survival of the fittest. Surely a frog with those menacing teeth will be able to survive better, be able to take out predators easily even when they're trying to grab it, be able to survive a lot better. So from evolution, keyword there, since we're talking about it, you can tell what evolution is very briefly. Anyone know what evolution is? Just come up with any answer, what you think.
Evolved from cells into fishes, fishes to apes.
Okay, so that's development.
Yeah.
But how about on the micro level? How about on the small level? What's actually going on to make that fish into something else? Do you know what's going
mutations.
on?
I think mutations, DNA changes.
Okay, DNA. So therefore, you're right, we have changes in species from one thing to another. So for example, a frog jumping out of the water and becoming a reptile, a lizard. Then that lizard develops on and becomes a mammal. And then that develops on and becomes an ape. And what comes after the ape?
Human.
Us, apparently. So this is the thing of evolution. You've got to change quite a lot. So for that to happen, you've got to have genetic change, i.e. DNA change, for that to actually happen. So what they define it as evolution is change of the genetic structure over time. Now, frogs have been around for a very long time. Why have none evolved like this? Why have they not evolved to a level where they are, you know, surviving, evolving to a better species, a stronger species? Yeah. This is just an example to show that, look, these aren't happening. Why not? Okay, but I want to show you some evidences. Okay, some evidences, because I think for me, science is really about evidence. If you haven't got evidence, I'm not interested in your theory. That's just me, and anybody. You should have evidence. Okay, so let's look at my first evidence to show that I think evolution has got huge question marks. Okay, right, natural history. Okay, in natural history, you've heard of fossils. Yeah? Fossils in rock. So in natural history, we see this. Okay, anyone know what it is?
Spider.
Obviously. How many legs has that got?
8.
If anyone's good eyesight. So, now let's see. If that's got 8 legs, and the one on the right hand side is a current day spider, do you see any evolution there? Do you see any change? By the way, that's not, that hasn't got all its structures there, that's just a fossil.
Just on upside down.
Yeah, probably. So the thing around it you might see, yeah, is rock. Okay, so it's actually been embedded in the rock and preserved. Because what happens is when something dies, the minerals inside it react with the rock, and then it just leaves traces. And obviously in that case, the traces have been composed of the body parts, and therefore you can actually see the structure. Okay, so that's how a fossil basically comes about. Now, do you know how old that is?
150 million years.
Yeah, if you read that, this is from the Upper Jurassic. You heard of the Jurassic, yeah? I think everyone's heard of Jurassic. Upper Jurassic period, which is about 150 million years ago. We're not talking about 100 years ago, you know, a whole century, not even 1,000 or 2,000. We're talking about 150 million years ago. Why hasn't that got 5 legs or 4 legs? And then eventually it slowly evolved 5, 6, 7, and then we've got the current day spider. Did you notice? They've actually got 8 legs, and it's the same body parts. It's got head, yeah. It's got that moulded body, and then it's not like an insect, which has got 3 parts: the head, thorax, and abdomen. Yeah. This, notice, is a spider, and it's still a spider. Nothing has changed. Now, what evolution is for them, it's quite basic. What are you talking about? You know, over thousands of years, you might have small genetic changes, but over time, what are you going to have? You're going to see proper changes, an extra leg, an extra tail, something coming about. But here, we're talking 150 million years. Is that not long enough to have changes? Yet, I can't see a single change in that. They've still got 8 legs, they've still got the same body parts, it's still a spider, 150 million years old. But someone could say, you know, in science, you can't just use one evidence, you've got to use a bit more to show that you've got some real evidence, to show that what you're saying is actually right. Anyone know what that is? Yeah, I've made it a bit easier for you because I've actually labelled it as well. Yeah? that's a good thing. Okay, now a bit more tricky, yeah? How many body parts has that got? Main body parts. You can tell me the body parts of that.
3, 4.
Yeah? 3? What are they?
Head.
Head and body. That's the head.
Head, the bomb.
What's the body made of? What's that?
Is butt.
Language.
A bit before that, abdomen, yeah? You've got your abdomen, your stomach, so to speak, yeah? You've got your abdomen, you've got the middle, which I said was the thorax, yeah? What comes out of the thorax is the legs. If you do actually count that, it's got 6 legs. And the new one, you know what all insects have got, yeah? How many legs they've got? 6 legs. This is, as you can see, yeah, not 1,000 years, 5,000 years old, which is pretty old. Yeah? This is 45 million years old. This is from the Eocene period. So we're talking about 45 million years of supposed evolution, and yet it's still got a head, antenna, thorax, abdomen, 6 legs. It's still an ant. You can see. Oh, by the way, that is not a normal fossil. That's actually embedded in amber. Anyone can tell me what amber is? Amber. No one knows what amber is.
Tree sap.
Made from what?
Tree sap, isn't it?
Right, okay. So we've got trees. I don't know if you've ever seen it, but sometimes trees put out like a gooey solution, which is really sticky. It traps insects. It's a defense system, yeah? In science, they call it a resin. It's like a glue, yeah? It's a resin, and it becomes really hard. And it's so hard, it basically just traps things. You've seen Jurassic Park. You've seen that mosquito that they use in taking its DNA out, especially in amber, okay? Now, the good thing for us people who look at real science, reality, and actually want to find the truth, Allah's preserved enough evidence from the animals around to actually see truth, in what we're looking for. Here you can see, again, no change. Yeah? I don't want you to just look at it and say, oh, is there change or not change? That's not good enough. What you should be thinking is, why is there not change? Because it's not good enough just to have a theory say, you know what, I think you're wrong, evolution. I just don't think you have an evidence. In fact, we've found evidence to show there is no evolution. It just stays the same. More than that. Because if you want to become an enlightened thinker, someone who actually comes to the correct aqidah, you'll be thinking, why? Why is there no change? What makes the ant still the same 45 million years on? Okay, so think more about that. That's what you should be thinking about as I'm going through these. Yeah? Not just the evidence, but why? Why is this going on?
Sorry, can we ask questions?
Yeah. Yeah, as long as it's short.
Just if someone wants to argue these are exceptions to the rule.
Okay. I mean, that's why I didn't use one or two examples. I used about 5 of these fossils and amber specimens. Yeah. And notice I haven't used the same type of thing, because in the book I had, we're talking about in the electric format, we had about 900 and something pages, and we're talking about thousands of specimens in fossil and amber of different types of creature. Yeah. And even when I thought that's not very good, they've got like a bear skull or a tiger skull. Even that I didn't use as my evidence. Why? Because I thought, okay, you got a skull, how about the rest of the body? Yeah, I wanted to use proper conclusive proof, not just the skull. I want to see the whole body and show that everything's the same. Yeah, so they've actually got thousands of evidence, different types of fish, insects, amphibian, right through to arachnids, and even mammals, which I'm going to show you right at the end, which is totally going to kill it. Even mammals. Yeah. So in fact, you could say evidence is not the 5 or so that I'm going to show in terms of fossils, but rather evidence is thousands, literally thousands. Even the book, by the way, which is called Atlas of Creation by Harun Yahya, it's on the website. Atlas of Creation. That's got 1,000 specimens, 1,000 proofs, and that's not even all. So Allah has given enough proof in the earth, as He says, ayat. He's given many ayat, many signs for people who are looking. Yeah. So for you to come to the correct understanding, you don't even need to be a scientist. There's many signs that Allah will give you. Even if you're Amazonian, rainforest Indian, He will give you signs. Look at the stars. Look at the moon, how the orbits are going, even the night and day, how it revolves. What's keeping that order? Something more powerful than me is keeping that order of the universe going. Yeah? Because these are heavy objects we're talking about. The planet Earth is not your 5-gram thing. We're talking about massive masses going around in the same 24-hour cycles, 365 and a quarter day cycles. It's the same, and it's going on. Who's giving that order? Who's making it spin like that? Yeah, that continuous order, the orbits. So all of this basically for people to think, even if you haven't got a science degree, it doesn't really matter, because anyone with their intellect, that's what we said, remember the aql, you can understand that things coming in order must have been ordered, i.e. there must be a designer who's put certain things in place to make it be like that. The opposite of that is what? Random. No order. But something which is designed and ordered in a certain way, it's like saying, if you read fossil, yeah, if you put F and a T and an R and an O, it does not make fossil. Yeah? So you can see that fossil, the word, the letters coming together, have not come there by chance, by random. I haven't just put any letters out of the alphabet and put them together. It's ordered. Yeah? It's from thinking what makes the word fossil these letters in that order. Therefore, you know that this thing has not been made, just come there in the wind, rather something has ordered it. Yeah? In the same way, you look at the bodies and everything else, there's a lot of order, which we're going to go through later about the body. Yeah? There's a lot of order there which proves that something's behind it, design it. Evolution again. You know what herring is, yeah? You can see herrings today. They're quite common fish. Yeah. Now, anyone want to tell me what are the main issues there you can see that are similar? Because there are quite a few. Just give me 1 or 2, just so we know that. Yeah. What sort of things? What sort of things are you looking at? What features? Okay. Roughly the body shape. Okay. Anything else? Any specifics?
You see the eyes,
I can't see the tail on the other one.
Yeah, assuming it's the tail.
I'm assuming there'll be a tail.
Let me try and help that.
Surprise!
There we are.
It looks like an
he's
X-ray.
tracking the same.
The tail, Notice how what sort of tail it is, because you've got other fish tails as well that sort of are together. This is like a 2-point tail, yeah, which is, as you can see there, quite clear. The dorsal fin, the pectoral fin, even the back fin there, everything is just the same. How old is that? 37 million years old. Same fish. Where's the evolution? Where's the changes in the DNA that's produced a different specimen, a different species? Nothing. Okay, so you can see, the evidence is building up in fish, even crustaceans. You know what that is, yeah? This time it's on that side, so anyone can guess what that is? Crab, yeah? Right, and one currently. Again, you can see the legs, you can see the big pincers on the front. It's the same thing. Yeah? Still got the exoskeleton, the hard shell. So everything with the crab has also stayed the same. Nothing's changed for 25 million years ago. It's still the same. And I think finally, so even if you want to come back onto land, okay, you can see a fossil from the Eocene period, 37 million years ago. And I think you'd recognise this. Flies around, and it's a mammal. In fact, warm-blooded, it's a bat. Now, notice certain things, yeah? That thin little tail there, and the one there, okay? Notice how the legs are very squat. You know, like back home, yeah, back in the village, when you go to the toilet, okay, you don't have these English toilets up there. You have to squat on your legs. This is very common position over there, yeah? So, why am I even saying that? Because look there, the legs, you can see, it's the same type of positioning of the bones. Nothing's changed. It hasn't grown longer legs, which can maybe help it grab things. Okay, it's the same. And notice the huge arms in comparison to the legs. Massive arms, as you can see in the comment that we count back today. Massive arms that basically reach out through the whole wingspan. And then you've got those other bones coming off, as you can see here. So you've got the same bat, the same little thin tail, the same spot legs, massive long arms, and the same wing that's obviously fossilised there. It's the same bat, and this is how old? Millions again. I think around 21 million years there as well. So let's see. Yeah, 37 million years there as well. So this is a mammal now. We're not even talking about insects and arachnids. We're talking about mammals now. Warm-blooded mammals have been around for millions of years and it's still the same. So I think we've produced quite a few evidence to show that, look, in terms of real evidence, by the way, people like Charles Darwin in the origin of species, yeah, all these things, all these people have basically looked at things like, oh, I see that fossil there, I see that fossil there. Maybe that fossil became that fossil, i.e. that organism evolved into that one. Has he seen it? Has he actually seen that change? He hasn't. No one's actually ever seen it. So there's actually no real evidence. But these are solid evidence, and I mean solid because it's in fossil rock. It's hard evidence to show that actually there haven't been any changes at all. And there's thousands of examples like the ones I brought. Yeah? So what evolution? There's a big question mark underneath evolution. What evolution? Evidence shows there is no evolution, they've actually just stayed the same. Okay, now, in terms of the big one that a lot of people talk about, apes. Okay, so I'm going to give you an example of what evolution could have happened from apes to human. Here we have an example. Anyone know the person on the right hand side?
Richard Dawkins.
Okay, who's Richard Dawkins? I've used him on purpose.
He's a guy who wrote a book called The God Delusion.
Okay.
Very famous guy who believes in evolution and things.
He loves evolution. He is pro-evolution and he hates God and he hates religion. Okay, that's why I love to use him in this example. Okay, here we have, as you can see, a gorilla. Notice how I put the arrows and how you've got that gradual change. Slightly lighter, a bit happier gorilla. And you can see the resemblance there as well. The nice turned head to the right, to their left, and a happy face. Yeah, so you can see the gradual evolution. Hold on, we exist. Even now we exist with them. They're still gorillas. They're still apes. You know, these sort of primates still exist. In fact, you know that humans and apes have been around together i.e., we're not talking about some fossil that you think might have evolved into the next one. We are actually there. We can live, in live format, we can see them evolving and changing over time. People can record them. But yet, for thousands of years in existence together, we have not seen any such change. Again, question: why? Humans have been around for thousands of years at least. Yeah, even ancient Egypt was 5,000 years ago. So therefore, humans have been around for thousands of years. Why have apes not evolved in that time? Not even a bit. They're still the same apes. Yeah. So it raises questions that if really we've evolved from them, why are now apes not doing this? And the second bit of that is that human. Okay. Why doesn't he or other humans? Why don't we change? Why don't we become the next thing, the next bit of human evolution? A superhuman, someone with maybe more legs, better structure, stronger structure. Why don't we change? So these are questions to think about. If anyone does think that, look, actually we came from apes, because that's what we've been taught. But apes have not actually changed in all these thousands of years living with us. Living with us meaning, in places that we can actually see their habitats, and yet they have not done that. Human evolution, again, for thousands of years, humans have not changed. We're still the same. We're still bipedal. We walk on 2 legs, generally, and we've still got 2 arms. We've still got 2 eyes, 2 ears. Nothing much has changed again. Why? Does anyone know why? Why we haven't changed, and why, in fact, all the other evidences I've shown have not changed? One word answer?
Evolution don't exist.
One word. That's a lot of words there. One word.
Nonsense.
No, why we don't change? Give it a D, keyword.
Well designed.
DNA.
No.
So therefore, we don't just change, and there's a reason we don't change. Yeah. Okay.
Scientists is going to argue against that. They'll say they don't say that we evolved from apes. We evolved from a common ancestor of apes. So apes and humans split from a common ancestor. That's what they say. And also, scroll up for a second. Oh yeah, why not humans evolve? What do you call it? Why aren't we evolving? They'll say we are. We're constantly evolving. Changes are happening in DNA. The DNA of the fat people nowadays, obesity and all that. That's because of the common change in the DNA. Body from the what's that word? When we're hunter-gatherers, basically, our bodies were designed to obviously consume a certain amount of food, and we have to gather and stuff like that. Now we sit on our asses all day, right?
Sure.
And we eat, and DNA has been changing, or stuff in our body has been changing, so we can adapt to that. That's what they'll argue.
Okay. Again, remember the key thing I said before: evidence. Yeah. In terms of obesity, I'll be honest with you. If I now start getting very happy with certain types of food, and we all know what sort of food we're talking about, yeah? Loads of crisps, I'll become obese very quickly, okay? I mean, it depends on your metabolism. My one isn't all that fast, so therefore, I'll become obese. That doesn't mean my DNA has changed at all. Because remember, they have to provide evidence. They can have theories, they can say, look, we are evolving. Where's the evidence? If you look at the human skeleton of before to the human skeleton of today, it's the same skeleton, and in fact you can go into the DNA there. They've got calcium, they've got everything that's still there. You can look at the DNA, and it's still the same. So the DNA of humans actually hasn't changed. What you can see is diversity. Yeah. So for example, an African man will not be the same as a European man. There'll be slight differences in bone structure, but that's not really. There is a difference in DNA in terms of characteristics. Yeah, there's a difference between species, i.e. you're a different category altogether, and just having slight differences. We don't all look the same. Yeah, there's certain features you can see, and I'm not saying this in any way to put anything down, because for me, it's irrelevant where you're from. But let's say, for example, in Africa, okay, there's certain common traits of people in Africa in terms of bone structure. For example, the nose is a bit more flattened. Yeah, in people in the Far East, in China, for example, the eyes are slightly slanted. Yeah, it's not in a derogatory way. It's just DNA. So yeah, of course, there's slight differences in DNA, but that's not evolution. What that is diversity, i.e., different DNA. When I say different DNA, I'm talking about the genes, the actual code blocks are slightly different, but they're not changing. They're just slightly different. Yeah. So therefore, that's just diversity. Allah in fact talks about that in the Quran. That I've made you different nations so that you might know one another. Allah said that difference. I've made you different. But that difference is not meaning I've suddenly become a lizard. Yeah? Or look, this guy is really bothering me, and in fact his whole family has been bothering us for hundreds of years, our family, let's now think of a new thing we can do to our children, okay? Give them another evolutionary trait that gives them the advantage, like that sort of claw that the crab had, so he can take them out. They haven't done that. The humans can't just evolve and have that claw just because he wants to. That's the issue, that really humans, if you look at their evidence, real evidence, hard evidence, not what I think, hard evidence, the human DNA is still the same. What you do see, which I think you're talking about, is slight differences in lifestyle and slight differences in terms of your genetic makeup, which is you as an individual, but it's still practically the same as any other human. Yeah, so that's just your little code differences, but the main bulk of it, i.e. the fundamentals, are still the same, which is why we're still all human. We're not an ape, or we're not a lizard. Yeah?
What about the prehistoric account, the 7 Homo habilis?
Okay, yeah, sure. Okay, then look at the Homo erectus. Yeah, you've got the Neanderthal. We mentioned Neanderthal. From Neanderthal to Homo erectus to Homo sapien, you go through that. Has anyone seen that change? That it was actually that ape, yeah, or that ancestor of the ape, yeah, which again, no evidence, but the ancestor of the ape becoming that Homo erectus, i.e., we're now getting, by the way, Homo erectus, erecting yourself, becoming higher up. You're not on 4 legs anymore. You're actually becoming 2-legged creature, yeah, to becoming Homo sapien, intelligent being, which is us, inshallah. Yeah. So has anyone seen that change? So where's that evidence? Where's that evidence that when they make that claim? Because we can see from thousands of years ago, the ancient Egyptians, they're mummified. Yeah. So there's still a DNA evidence about them, and it's still the same. The DNA is the same. So this thing about prehistoric, so-called prehistoric humans, in fact, it's a good thing you said that now, because we've actually come on to Neanderthal Lucy. Has anyone heard about Lucy? The Neanderthal Lucy? A few years back, before our time anyway. There was a skeleton found, okay, preserved. So like when you have these things on mountains, or where there's a lot of ice, or where it's dry land, they've got preserved remains. They thought, okay, we've done it now, evolutionists. We have found the transition state, where you've got this organism to the next organism. We've now found the one in between that everyone wanted to know, the transition one. That's which is what you're talking about, that transition state, where you're changing from 4-legged slowly to 2-legged. So we want to see the change. But what we found, you know what anatomy is, yeah? It's about the human body, the shape, the structure. Anatomy, by the way, these anatomists are not Muslim, and in fact they're actually evolutionists. Zuckerman and Oxenham. Yeah, I made sure I put the names in, just in case when you Google search and make sure this guy, is he really coming with the truth, or has he just made things up? Okay, so if you want to check it, anatomists Zuckerman and Oxenham have actually done the research. They're actually pro-evolutionists, so they want it to be the transition state. But they've proven from their studies, from the bone structure, that you know what, this no way is a human transition. In fact, they've said outright, this is an ape. It's Lucy the ape. Okay, it's just an ape. So these transition states that they found in prehistoric times, these are just more apes. There are different types of apes. A gorilla, yeah, and a chimpanzee, they're not the same. There are different types of apes, different types of primates, and orangutan. So therefore, clearly, they're just differences. They're not a human, or a transition state of a human, because human is very different. Okay? So all they found in those prehistoric things are just other apes. Yeah, other creatures who are clearly not human. Because humans have got a certain type of skull structure and everything else. Yeah? Okay, now, some things that you might have heard about natural selection, diversity and adaptation. Has anybody heard about the peppered moth doing research on evolution? What some people say, okay, here's a peppered moth. Look how during industrial times, like in Britain, when it was really smoky and all the coal they were burning, that white moth didn't stand a chance because predators could see it from a mile away. Got eaten up, and they say evolved into that black one, which moulded with the trees, moulded with the buildings, with all black. Yeah, so basically evolved into another one from natural selection, from selecting what the environment gives you so that you can survive, and here we are. Evolution in reality. But what they did tell you is actually, you know what? They both existed at the same time. The white one and the black one were existing together at the same time. There's no evolution. In fact, the The zoologist will tell you they're actually the same species. Evolution is changing species, not the same species. The peppered moth, black and white, are the same species. You know what changes? Okay, you've got change in colour. Yeah, and we'll go to another change in colour. Change in colour. So we're talking about external colour changes, but it's the same moth. Yeah, same species, but there's different types of humans, as you can see, with different features. All of us have got different features. In the same way, moths have different features. It just turns out that the predators who saw the white one saw it easily amongst all the black soot and everything. They took it out easy, and hence you had less white and more black. When times are more cleaner, like now, I think England is a bit cleaner now. You've got industrial revolution, so now the black ones will be seen amongst those white buildings, and therefore they'll be taken out. Hence, you have more white, less black. That's to do with adaptation, how you adapt to the environment. It's not evolving, your genetic structure is not changing, so it's still not evolution. Do you know what that is on the right hand side, which I'm going to show you a bit more of?
Chameleon.
Okay, say it again. Right. It changes colour, as you probably know. Yeah? What makes it change colour is, again, not evolving, not making the DNA change. What makes it change is, as I put there, the chromatophores. Can anyone guess what chromatophore is?
Organelle.
Huh?
Possibly.
What's that?
Organelle.
Okay, what does it do?
Changes probably enzyme chemical structures and that.
Okay. Chrome is to do with colour. So it helps it change colour, basically, yeah? Certain cells, chromatophores are basically cells. They're cells that change colour. We haven't got them, obviously. Yeah, for me, if I go back home in all the sun, yeah, I'm going to become a bit browner. Okay? There's melanin in us, which is brownness. Okay? Whereas if we come here, it's a bit lighter because there's not so much sun and direct heat. Okay? That's just normal adaptation. Why do we do that? Because melanin, if you don't do that, as some people, with freckles and stuff will know, they start burning. Yeah? It's just nature. So therefore, these things have to actually blend in with the environment and for other reasons like reproduction and stuff. They basically change colour. The chromatophores. Again, notice not DNA changing. Yeah, it's just external features, cells that actually change. Okay. Right. Coming on to this new other organism. What's that hanging on the tree? You see that? What's that hanging on the tree?
That's some weird.
Should you quiet?
Okay, now you
Sloth.
I've even put in the description of it as well. It doesn't do very much. The scientists have said, you know what? Its legs are very weak. Okay? It hardly moves. You know what it does most of its time?
Eats.
Sleep.
It sleeps most of its time. Oh, by the way, that's from South America. So if a jaguar pouncing up saw that lazing around on the tree, one pounce and that's dead. What else lives there? Monkey-eating eagles. They don't even have to pounce. They can from down below. They can come from the sky with their eagle eyes, spot that hairy thing and just take it out. Yeah. Snakes. That's the land of anacondas. South America, the Amazon. Anacondas can wrap around it. You got a nice meal there. So we've got various predators that can just easily make that extinct. Forget the dodo. That can still run. This can't even run. It can hardly walk. And you know what that is, by the way? All that bushiness. Obviously, it doesn't have a haircut. But apart from that, all the infestation is breeding there. We're talking about microbes breeding on that because it's just so dirty. Monkeys and other things at least clean themselves. It's not that much hygiene. They sort of lick each other. Yeah, they can't even do that. They've got a very low metabolic rate. They're just out, meaning they should not exist. And by the way, do you know how long they've been around? At least thousands of years. Why don't they die out? Or why don't they evolve into something a bit more active? But yet they're still around. They're not extinct. Why? This flies in the face of evolution. It's not evolving. Okay, so you've got the sloth. You've heard of the giraffe in this too, yeah? If you've looked into evolution, how a horse develops the neck becomes longer. Yeah, the giraffe, classic example.
You said 1,000 years it's been around.
Thousands. I've just said thousands. And even that, I haven't studied hard.
How did they come about?
How did they come about?
Yeah,
From the start?
Thousands, yeah.
No, it could be millions. I'm just saying at least thousands because I wasn't there.
You mean a long time.
Yeah, a long time. Yeah, I'm talking about. Those fossils, the reason why I can say it is they've actually dated the fossil. They've dated the actual rock, which is why I can say 37, at least 37 million years. Here, I'm not dating it because I've got no evidence, which is why I'm just saying thousands, at least thousands. Okay, that is an okapi. Yeah, an okapi lives in Africa as a giraffe does. Same savanna land, same forest. You've got an okapi, and notice the neck, nowhere near as long as the giraffe. Now, do you know the oldest records of the okapi is not from Attenborough? The oldest records are from ancient Egypt. So we're saying at least 5,000 years, at least. That's just from records. At least 5,000 years, that's been around with its small neck. By the way, the giraffe and the okapi are very similar in terms of species. So people have said, that should become that, or something like that was around, which became the giraffe. But you've still got the okapi. It's no way can it reach all those high trees, yeah? So therefore it should either, one, evolve, get the longer vertebra in the neck, yeah? Grow a longer neck, not itself, but its offspring. The DNA should start changing in its offspring so that its children and their children start getting longer and longer necks until it becomes more giraffe. But the okapi is around 1,000 years, they still haven't grown longer necks, and neither have they become extinct, which is the other option. If you don't compete, survival of the fittest. If you can't compete, you either die or you evolve. They haven't evolved or died. They're still around together. Another proof that, look, forget okapis becoming giraffe. They've been around 1,000 years. They're still the same short-necked creatures. And you can see why. You've still got grass on the ground. You don't need to go to high up trees. So it's not a case of you have to evolve to survive. The classic one for Charles Darwin, yeah, the original species. He talks about finches, birds with different beaks in the Galapagos Islands. Yeah. So I've used two different birds. One is actually a finch. One here. Notice their beaks. So here's an example. I'm a bird, let's say. Yeah. I come to a certain island where there's, let's say, a lot of meat. Okay. So I have this as my beak. But now I just fly off to the next island and I find, where's all the meat? There's hardly any animals here. All I've got is little insects and seed. This sort of beak is not going to come very used to get all the seeds and pick them up and insects. So let me now change my beak. Yeah, you've got mobile phone accessories. Change the beak in this case and become like this. So I've adapted to the environment. Does that happen? Do birds just suddenly change their beaks? How about their offspring? How about their, like eaglets? Do they change their beaks? Do you remember the key thing I asked you to think about before? Yeah. What is it that doesn't make them change? That keeps the same sort of things going on and on through generations. You remember that?
Yeah.
What was it? DNA. Absolutely. So you can see why the eagle does not become like that. There's something in it that gives it characteristics, whereas that has got its own DNA, which is different. So you don't change just because you go to a different island. Yeah. Clearly, Darwin was wrong. In reality, birds don't do that. Right, now, evolution in action. Look at the children now. Let's look at their offspring. Look at the resemblance. Yeah? Notice how a lion cub is always like a lion. You know what the thing on the right is, yeah?
No. What?
Look at it carefully. What that thing on the right hand side.
Crocodile.
Yeah, so let's just say crocodile, yeah? Okay. By the way, how many crocodiles on the right hand side?
Two.
Yeah. You just like see the parent's head and the little baby croc on top. Notice again, it's the same. It's the same sort of species, same features. Why? The DNA. So things don't change just because they want to become better or stronger or anything like that. They stay the same because of what's inside them, what's been put there inside them. Not that the parent can say, I want a better life for you. Yeah, so I'm going to change your DNA. I'm going to go in there and change it. The lions, the crocodiles, they don't do that. Clearly they stay the same. So evolution doesn't stand a chance. When we look at real evidence, this is what happens. Yeah? But why does it happen, as we said? DNA. What does DNA stand for? I hope you know. What's DNA? We said DNA a few times today. What does it stand for?
Designed actually by Allah.
Deoxynucleic acid.
Okay.
Deoxyribonucleic acid, I think.
Right. So yeah, DNA, deoxyribonucleic acid. Okay. In my version though, I personally think I've got better abbreviations for it. Designed, nature, because it is designed. You will soon go into what, how you can see that. By Allah, clear. Look at those things. Yeah? There. Notice those chemicals that make up the DNA. You see, they actually go in a certain pattern. Certain things won't go with other ones. Certain bases that come together don't go with other bases. You've got actually, there's actually four I put here. There's actually another one as well. So you've got adenine, guanine, thymine, uracil, and cytosine. Uracil's not in this one. So these are the bases, and as you can see, they've got certain shapes, well at least I've shown them as certain shapes, because they fit in, they fit together in a certain format. Yeah? So you've got an alpha helix, you've got different, and you know what's inside the DNA, yeah? Genetic material. So you've got a code. What does the code tell you to do? What's this code? What does the code tell the cell to do? Yeah, it gives it the features. So you know what we've just shown about lions and crocodiles and humans, yeah? This is what does that. The DNA gives it the code. How to, it's like when in science you have a method, how to make the next one. Yeah, this is its method. This gives it. In fact, the only time you do have, as you said, mutation, change, is if it's defective, if there's a problem there. It's not the norm, yeah? It's when there's a defect. When there's a defect, you have one of the things not working properly, and hence you have a defect. That's it. But in normal cases, which is the huge majority, you basically have certain bases sticking together in certain ways and gives the code for the next generation, the next cell. Which is why, if you've ever seen the cloning experiment, Dolly the sheep, the child of Dolly the sheep is another Dolly. It's identical. Yeah? But obviously, when you have parents, male and female, you have shared characteristics. But this is it. So this DNA, designed nature by Allah, it's designed, it's specific. It doesn't just come in any random form. The codes have to be specific. Because if the codes aren't right, okay, that thing will fail. The heart won't be formed properly. The liver won't be formed properly. You haven't got a second chance to evolve and then correct it, because you're already dead. You can't even have children, because you're already dead. If you haven't got a proper heart working, or a proper brain working, I don't think you're going to live long enough for your offspring to actually grow. Meaning you're already dead. Yeah? So there's no way that evolution can keep things going. Rather, DNA has to be perfect, has to be correct from the start. Which means it has to be designed and put there correctly by an amazing creator. Okay, finishing up, because another time is going. Something amazing. Now I'm not into defensive stuff anymore. Yeah, I'm going to be offensive. We've had enough of just proving evolution as being wrong. Yeah, enough evidence, fossils, amber, to looking at how things are staying the same. Enough. Now let's go to the next level, which is saying, okay, evolution is wrong. So what? How did all this come about? Yeah, this is evidence of creation. That's what we're moving on to. Evidence of not changing in evolution, but evidence of something being designed, created. This is what? It's the heart, yeah? Now, the heart's made of what, generally? What's the heart made of? Muscle, yeah? Look at, when you run for quite a long time, what happens to your muscles?
Get out of breath with it.
Yeah, you get tired. Yeah? Sooner or later, it doesn't matter how fit you are, sooner or later, your muscles will be tired. That's the nature of muscle. Now, forget your legs, let's look at the heart, which always has to continually pump. Yeah? If your muscle is pumping away like that, what's going to happen to it after a certain amount of time? Fatigue. And then what's going to happen to you?
Finish.
Absolutely. Absolutely. You know, there's a big one, a big tube, a vessel that goes to your brain. It's called the aorta. If that stops for a few seconds, your brain cells go dead, meaning you are gone. Okay? Or your heart is stopping and then you can come back to life again, as people say, with a bit of resuscitation. No, when your brain goes and Allah has given it for you, Azrael comes down, you're gone. So if the aorta stops pumping oxygenated blood up there, you're gone. Meaning, something has to keep that going to make sure you stay alive. What is that thing? I think I'll put it on the top so that you see the label now. The SA node, the sinoatrial node. That is that little yellow dot there. It's like an electronic device. Okay? An electronic, you can call it a pacemaker. What it does, it gives electronic impulses, signals to the heart. Here you go, beat. It just pumps blood. Then it says rest, in effect. Rested. Rests and rests, as you'll see then. Rest for quite long. Then it just goes pump again. So it pumps. Then it goes rest again. It's giving it all the rest at once, not like a normal muscle. So that electronic device, let's call it, a sinoatrial node, SAN, you can Google search it, SA node, it basically keeps the heart resting for long periods within the beats, within the pumps, yeah, within the contractions. Meaning, something has put an electronic device there, sending electronic impulses, and notice how the yellow, you see the yellow network. It's not just that yellow dot, you can see a whole network. Who's put the wiring together? Yeah, that's the basic thing. Who's put all that electronic wiring there in the heart to make things continue? To make you stay alive? Think about it. The sinoatrial node, clearly, it keeps you alive. How did it get there? Did your parents, do the engineering, the electronic engineering, and put it there? Did you put it there? How did you get there? Anyone can hazard a guess? How did that electronic device get in your heart? Basically, that is not some random evolutionary thing. That is an electronic device specifically connected correctly to keep you alive. You owe your life to whoever made that SAN. Yeah? Something, whoever designed it and put it there, i.e. the creator of all the atoms and the universe, yeah, we owe our lives to Allah subhanahu wa ta'ala. So you should serve Allah. You should worship. Because clearly that's the sign of creation. Moving on and finishing off, in fact, another quick one, this won't take too much explanation. Bacteria, you all know. Okay? Bacteria flagella is like a tail that basically moves it along. Okay? Notice how many, you might even like think that's a bacteria, look at all the parts, like a rotor. And it's actually, the rotor is part of that motor. And you can see the S ring, the M ring. Now imagine if one of those parts is taken away. It hasn't evolved yet. What's going to happen to that tail? Is it going to work? Is it going to move it along, be motile, if some of the parts are taken away? Let's look at one part, here, the hook, which actually connects the tail to the motor. Imagine the hook's not there anymore. The tail goes flying. There's nothing to connect it to the motor. So what's going to make the tail go? It's just going to fly off. So every single part of that has to be there in one go. It can't be evolved. You can't evolve over time because that means you've got parts missing. If you know a car engine and you take away parts of that car engine, is that car going to run? Simple. It's just so simple that you can't have evolution here. It's all got to be correct in one go, which means it's been designed correctly by Allah subhanahu wa ta'ala. There's no way that can evolve because parts will be missing, which means that thing will not work, it will die. End of story. No offspring. No bacterial infection. Okay, now, just to finish off now, yeah? How should we think? We said evidence. These words, you know what the words are, yeah? The letters in there. The Quran. So, as you're all doing right now, in fact, you're looking at those letters and you're doing what to? You're sensing that reality. What is he showing me up there? What are these letters and what does it mean? That's what the human brain does. That's how it functions. You interpret that. So, reality, that's a reality, you've seen it. It goes to the senses. So in this case, I've got a telescope there, meaning you're looking at that word, okay? Your eyes, and then you're forwarding it to where? That. You know what that is, yeah? Okay. That is a real brain, by the way. I haven't used images and things, I'm using real stuff. This is the real brain, okay? So, your image, I didn't use other ones. There were other images I could have got which were blood stained and stuff, and I thought it wasn't very nice, so I used one that was dried out. So you've got a real brain taking sense of reality. What senses have you got?
Eyesight.
Okay, vision, touch, smell,
Taste.
Hearing,
hearing, and taste. Okay, so you've got 5 senses. Maybe. Okay. What's that?
Muscles.
Muscles?
Yeah.
Is that a sense?
I think so.
I mean, especially it was movement, isn't it?
No, when we lift.
Okay,
That's touch.
That's part touch.
Yeah.
It's part touch. You know, touch has got different form. You know, heat.
When you touch something, you want to see that
Okay.
material.
Okay.
So you can do it with your finger. You can see.
That's fair enough. Yeah. What scientists do, they just put it all together in one bundle called touch. Even when you feel heat, you might think I'm not touching anything, but you just feel in the room and it feels hot. That they call touch as well. It's just your sensory touch, meaning the receptors on your skin. That's what they mean by that. So you're correct. That's the sense.
You know, if you go to the gym and
You feel a different sense there, yeah?
Yeah.
Okay. Whatever sense you use, yeah. You've seen that. You've seen those letters, yeah. The Quran, right? Whatever sense you use. So your senses relay that to your brain, which you've all got. Okay. And then what else have you got? The brain does what? It processes that information. A processor. Yeah, you haven't actually got a Dell inside your brain, but it's a processor. So it processes the information with previous information. What do you know about that Q? What do you know about the U? What sound does it make? And when you put the sounds together, what word does it give you? That's what your brain's doing. Even when you've seen that, you probably did it like that. You probably didn't think very much. Yeah, I'll give you a nice easy one. But the point was, your brains were doing that all the time. I didn't need to explain to you what that was. You could just see it and your brain would know it, literally very quickly. So therefore, that's what is known as intellectual thought. You looked at a reality, you've sensed it, yeah, looked or heard or whatever, you've sensed that reality, you processed that reality with your brain, and once you've processed it, comparing it to previous information, it gives you, what does previous information do? It just gives you an idea about that thing. Yeah, that strange stylistic cue, what is that? That's all that the previous information does. You've learned the alphabet, so you can compare it to what you already know. That's what previous information is. You compare it to what you know. And then you can form an idea about that thing, and a thought, okay? And then what does that give you? It gives you this. You can picture it. Yeah, when you look at the words and you see Quran, that's what your brain probably thought of. Oh, I know what that is. It's a kitab. It's Allah's word. You thought of a nice shiny Quran, that is, well, yes. I don't know if you're wondering what that is. Nice shiny Quran. So the issue is, those letters, I didn't even need to really go through all this and tell you what that was. You probably already knew. You probably were thinking something along these lines. You probably had a picture in your head about what you just sensed, those letters. That's what your brain does. That's what I want you to do. Not now, all the time. As in, when you go in life and you want to look for the truth, you have to be using reality, sensing it, processing it, comparing it to what you already know, but only use facts and reality. Don't use funny theories, use reality, what you can tangibly know. Yeah, that's what I want. Hard facts, process it, and then you have the idea, the correct idea, because you used correct reality. Yeah, not some story. Use correct reality to give you the correct ideas. And once you've got the correct ideas, you've got the correct aqidah. Because that will give you the basis. That will give you the correct understanding of reality. And therefore life and the Creator as we've gone through. Okay, so we finish there inshallah. And then, I know already we've made it interactive and you already asked some questions, which is good. But I'm going to make it open, so if there's anything there which maybe you didn't spend enough time on, or you want to ask more questions or comments. Are you also?
What is it? It's the carotid artery. The aorta is the arch.
It goes from one part side of the heart to the other.
No.
Is it?
No.
Oh, fair enough.
Let's have a look at it. Yeah?
What's the jugular vein? Isn't that the same thing?
Yeah, because then it's a vein. It also goes up. Yeah.
Because Allah talks about that vein as well, doesn't he? About the jugular vein.
Yeah.
Okay, so you've got the vessels going to the brain, yeah? Some of those basically go to the lungs. Then you've got the one that basically goes to the actual parts of your body, like your legs, your muscles, okay? And then you've got the one that goes to the brain. Now, the issue was though, and the reason why I was giving the brain example was because if it stops, yeah, forget the ones that go into your legs, because you might become paralysed, like a stroke. You might become paralysed, etc. But the reason why I gave the example of the brain was because it is very clear that even a few seconds too much and you are dead. So, and by the way, if your first point of call, your SA node fails, did you notice the second one?
Yeah.
I don't know if you noticed, because I didn't mention it. There is a second one.
There you go, backup.
Yeah.
Allah's even created a backup pacemaker.
AV node.
AV node,
That's technically
atrial
not
ventricular.
backup, though.
What happens is if the first one fails, the second one produces those same pulses of contraction, yeah, and then the same depolarization and repolarization. It goes for the same recovery, as you can see there. Those are the actual contractions of the beats, and then you have recovery. Yeah, the contractions, and then you got the recovery. I think you've got the T wave. You've got the actual recovery of the chemicals, and so that it basically rests and they can function again. Yeah, but my point on that was quite simple. That basically, if that stops, if that doesn't function right, yeah, if the DNA is not right in the first place, you are going to die. So therefore, and that's only for a few seconds. So we're saying that basically, look, this is not through anything but specific design. It had to be there, the DNA correctly, and I'll just show you now. It's even got backup.
Which location is it on the left side?
Yeah, well, it's on the heart.
Yeah. How does it go into your brain?
Okay, we did put the connection there. Yeah, it goes through the left.
Okay.
So therefore, but the actual SAN is located on the right atrium, which is on the right, your right side. Yeah? And the AV, atrial ventricular, is your secondary backup. Well, I mean, just to understand, I don't want to go too much into technical stuff, but the main issue, yeah, the issue is this has to be designed so correctly, because if you have the wrong type of pulses coming out, your heart would just be giving up and failing. So therefore, it has to be right. Yeah? And it can only be right if there's one thing, which is that it has been put there, coded and correctly, so that it can function correctly. If it goes too fast, too slow, let's say you've just hit the savannah, a lion's coming, you need to run. Yeah, here we go. So you're telling your legs to start pumping, but it's not working. Why is that? Because your heart's not ready to pump. It's still resting. Yeah, it's still resting. So if it's too slow, too much rest, it's not ready to contract yet, that's also going to make you die. In terms of survival, that line's going to get you. So you have to have the right sort of pulsing going on there. It can't be too slow, it can't be too fast. Yeah? And who makes it correct? The designer who's done it. So that's, we can see that there is the creator behind all these things.
Is it related to the adrenaline?
I mean, adrenaline does affect the muscle things, yeah, but that's produced from the adrenal glands, which is more the kidneys. Yeah, not necessarily this, but it is related. It's related.
And your point here is really the complexity of, just looking at the heart, for example. There's one example in hundreds, if not thousands, of different examples.
There's tons of other examples.
As opposed to the random stuff that we've spoken about, which isn't backed up by fact.
Absolutely.
But even if we take away the examples, you look at the random scenario they talk about evolution. Here's something which is, perfect.
Hard
science.
evidence, correct.
Yeah, as opposed to random, and they think that
Conjecture.
something organised comes from random. It doesn't even make sense when you think about it in today's reality.
Absolutely. I can give more examples. This is just one I thought was, to the point. There's other examples. I mean, I don't know if you know about the nerves of the body. Again, like when you've got, this is a good example. You notice what this is covered by? Yeah.
These guys are volunteer.
You know, the inside you've got like copper wires, yeah? Copper wires, electricity going fast. What's that covered by? Yeah, insulation. Yeah, one type of insulation. Did you know that your body's got wires as well? The nerves that make the electric impulses go through. Did you know they were actually insulated? So which electrician went and insulated your wires so that, have you seen Muhammad Ali?
Yeah.
The boxer, and his current state. Yeah, he's no longer rumbling in the jungle anymore. Yeah, you know how he's moving. Yeah, and the reason he's moving like that is those electronic impulses from the brain tells the muscles what to do, but it doesn't go there properly because his one, the myelin sheath, the insulation is not working properly. It's not properly insulated. That's why the electricity passes to other areas. It goes slowly along. It doesn't have that fast super highway that goes to the muscles. You see, so if you haven't got the myelin sheath, that's what it's called, the myelin sheath, yeah, which is that sheath, that covering, myelin, produced by the Schwann cell. Basically, I mean, all this stuff you can Google and research to make sure this guy is actually coming out with the right facts, or is he just, pulling one over. These are all facts. You can check the myelin sheath, MYELIN. The myelin sheath is another example of insulation in your nerves. Just a quick one on that though. You could think, okay, so what if you've got insulation? Okay, it could just be random. Your brain, that's also made of neurons, nerve cells. Imagine that being insulated inside with myelin sheath. How would your interconnecting wires actually process, like we said, process information? How would you process information quickly, which you need to survive? How would you do that if it was all insulated? But do you know what? Again, this is why it's not random. It's very well designed. The outside of the brain is actually, as well, it looks yellow there, the dry brain, but it's sort of whitish. So it's insulated outside, but inside, what do they call the brain? Another word? Grey matter. Inside is grey, not insulated. So the network, the neurons can actually function together, interconnect like a superhighway, like an internet. You've got that network which can go very quickly. The electronic impulses can just fly along it, superhighway. Because you need to process information very quickly. You can't afford to have insulation in between your neurons in the brain, because otherwise you'll be very slow in thinking, goodbye, you can't survive. So that's an example that even though your nerves are insulated, your brain nerves certainly are not. The neurons there are not insulated, except outside. Inside, they're not insulated. That is design. That's not random. Whoever made the nerves knows what they're doing to make you survive.
Yes.
Again.
Stephen Hawking is paralyzed from the neck down. So his heart is still pumping. Of course, because he's still alive.
He should say Alhamdulillah.
Yeah, but it's from the neck down, it's paralyzed.
Allah gives many signs. I mean, the point is, Allah has made things properly. Clearly, He's given ample examples of the amazing design. But Allah has also, sometimes as signs, sometimes as tests for humankind, given some faulty DNA, which actually does give you sickness, illness, and all sorts of other issues. These are sometimes warnings to mankind that firstly we're weak. You might think, look, I'm an amazing being with all these features. I'm just all powerful, like Fir'aun did. I am God. So therefore, Allah has also put defects there as well. This is not in terms of any limitation of Allah. Allah can obviously design things perfectly, but Allah has, on purpose, which is part of the perfection, on purpose done certain things to make mankind, insan, realize that he is weak and needy. He's reliant upon Allah. So that's why I gave said the thing about the response to Stephen Hawking. He should say Alhamdulillah, because he should think the fact that he's still alive. His heart, like you said, his heart is still pumping, even though he's got another defect. People should realize I'm weak and needy. I obviously can't exist by myself. All of these networks and wires have been connected in me properly. Other ones clearly are not functioning in me properly. So who has actually done all this? Who has actually made all these things go so I'm still alive, even with the other 40 ones in me? They should appreciate that. Because the way I see it is, Allah has put certain issues, let's just call it issues, on purpose in certain people. They should realize from that, that they're very weak and needy, and really they can't survive